Greetings, pre-calculus students, to another day in our unit on trigonometry on the unit circle. Today is our third day of looking at solving trig equations, and our final day, actually. So today we're going to look at one more type of trig equation you can expect to see, and it's one where you'll see multiple trig terms in it. So not just a single sine or a single cosine. No, you'll see multiple sines and cosine in the equation. And we'll talk about one method which you can use to solve said equations. But before that, let's quickly review the bell ringer. Okay, so in today's class, we started off with a bell ringer. So we're going to quickly review those solutions right now. All right. So factoring. A little review of factoring. So let's say you're given a function such as this, 4x squared minus 2x is equal to 0, or I'm sorry, an equation such as this, and you want to solve for x, right? You want to find the solution that would make this equation true, okay? Now, one method that is very common, or one type of method that's very common in equations such as this, is this idea of using factoring, or more specifically in a type of an equation such as this, factoring out a common factor, okay? Factoring out a common factor, something that we can take out of both these terms that they both have, okay? So in this case, you will see that we can factor out a 2x. Why? Because think of that as the greatest common factor of both those terms. It is the largest number that goes into both 4 and 2. And then you can see that both of these terms have x's, so we can also factor out an x. Now, for those who are a little bit iffy on how factoring works, think of factoring, so whenever you factor out a term out of an expression, whenever you factor out a common factor more specifically, think of it as you're dividing both terms by whatever you're factoring out. So in this case, since we factored out a 2x, right, we factor out a 2x, which you can see on the outside of this parentheses, what we in essence did is we took both of these terms, 4x squared and 2x, and negative 2x, and we divided it by 2x. Okay, so we took 4x squared, divided it by 2x, so the x squared and the x's, the x on the bottom cancels one of the x's on top, so that's why you're just left with x, and then 4 divided by 2 is just 2. So you end up with 2x. Okay, so the 4x squared just becomes a 2x because we factored out a 2x, or we divided it by 2x, in other words. And then the 2x term, the negative 2x term, right? If we take that and we divide it by 2x, we end up with negative 1. Because the 2's cancel out, the x's cancel out, and all you're left with is just a lone negative, so negative 1. So that's why we end up with a negative 1 inside this parentheses. Okay, so once again, whenever you're factoring out a common factor, you're in essence just dividing the terms by whatever you're taking out. So in this case, 2x. Okay, so at this point, remember, we are trying to solve this equation. Is we take, if I erase this, both of these factors that we have. So we have two factors at this point. We have a 2x and we have a 2x minus 1. We take each of those and we set them equal to 0. Okay, so we take each of those separately and we set them equal to 0. 2x is equal to 0. 2x minus 1 is equal to 0. Okay, because, right, if this times this is equal to 0, that means one of these has to be equal to 0, right? That's the only way you're going to have a product equaling 0, is if one of those is equal to 0. So we have two equations at this point. 2x is equal to 0, and 2x minus 1 is equal to 0. So we just solve these at this point. Okay, so divide both sides by 2. So x is equal to 0. Add 1 to both sides of this equation. So 2x is equal to 1. Divide both sides by 2. So x is equal to 1/2. Okay, so that's how you have your solutions of 0 and 1/2. So now let's look at a trig example using this method. So let me go a little bit forward here. We're going to skip that for a second. All right, so here's your equation. You have 2 cosine squared of x minus square root of 3 cosine of x. All right, so just like the previous problem that we just did, well, what do these two what do these two terms have in common? Well, let's see, they have a 2 and a square root of 3, nothing in common there, but they do both have cosines. Sorry, they both have cosines, right? This term has a cosine, this term has a cosine. So we're going to factor out a cosine of x, okay? And once again, when you factor something out, it's the same thing as dividing by that factor. So once again, all we did here is we took that 2 cosine squared of x, divided it by cosine of x, because that's what we're factoring out. So that cancels out the squared part, so you're left with just 2 cosine of x. And then for the radical 3 cosine of x, right, we took it and divided it by cosine of x. That cancels out, and all you're left with is the square root of 3. Or negative the square root of 3. Okay? So once again, you're taking out a common factor, something that they both have in common. All right, so at this point, just like the previous problem, you separate them. So cosine of x is equal to 0, and then 2 cosine of x minus square root of 3 is equal to 0, and you solve. Okay? So now for the first one, we have cosine of x is equal to 0, so we got to look up our values on the unit circle. So let's see. The places where cosine is equal to 0 on the unit circle would be pi over 2 and 3 pi over 2. Because the x value is 0 at those two angle measures. At pi over 2 on the unit circle and at 3 pi over 2 on the unit circle, the x value is 0 at those points. Okay? Now, what about the other one? Well, the other one we have to do a little bit of math. Let's see, I think it's no. So we have the square root of 3 plus the square root of 3 to both sides. So we end up with 2 cosine of x is equal to the square root of 3. Divide both sides by 2. So cosine of x is equal to square root of 3 over 2. So now we just have to determine where cosine is equal to the square root of 3 over 2. So if we look up the values on the unit circle, you would see that they happen at pi over 6 and I believe 11 pi over 6. Hopefully. At those two radian measures on the unit circle, the x values of the points are square root of 3 over 2, respectively. And then that's it. So you can see here we have 4 solutions for this problem. We have 4 solutions for this problem. We have pi over 2, 3 pi over 2, pi over 6, 11 pi over 6. Yeah, pi over 6, 11 pi over 6, okay. And there you go. All right, so now let's look at another way to factor. Okay, let's look at another method of factoring, which is a little bit different. Factoring by using sum and product. Factoring by using sum and product. So this goes back to possibly Algebra 1, and if not Algebra 1, then Algebra 2, this idea of having this kind of equation. X squared plus 8x plus 15 is equal to 0. A quadratic, for those that remember. X squared plus 8x plus 15 is equal to 0. Okay? So this would have been your second bell ringer problem. So factoring by using sum product. So whenever you have a quadratic such as this, okay, so you'll see you have 3 terms, x squared, 8x, 15. So you have 3 terms, and then you have that x squared term. The way you factor these is you look for 2 numbers. Okay, you're going to look for 2 numbers. Two numbers that multiply to 15. But add to 8. Okay? So in other words, you're basically looking for 2 numbers that multiply to give you the last term, or the constant term, so 15, but add up to give you the middle coefficient, so 8 in this case, whatever the middle coefficient is. So 8 in this case. Okay, so 2 numbers that multiply to 15 add up to 8. So there's a little bit of guessing and checking. A little bit of thinking about it. So the easiest way to think about it is what are two numbers that multiply to 15? 5 and 3. 5 and 3 multiply to 15, right? 5 times 3 is 15. And 5 plus 3 is also 8. Okay? So those are the two numbers that we want. 5 times 3 is 15. 5 plus 3 is 8. Those are the two numbers that we want. Well, what do we do with those two numbers? Well, now, now we're going to put it into this form. We call this factored form. Okay, we put this into this form, factored form. So we have x plus 5, and then x plus 3 is equal to 0. Okay, so you simply take those two numbers that you found, and you place them inside of parentheses like so. Okay, so x plus 5, x plus 3. And now we can solve it just like we solved the previous problem, right? We separate each of these and set them equal to 0. So x plus 5 is equal to 0. X plus 3 is equal to 0. So we end up with x equaling negative 5 and x equaling negative 3. And then you're done. Okay, so that's factoring by using sum product. So now let's look at a trig one. Let's look at a trig one where you factor by using sum and product. All right, so we did that one already. All right, here we go. So we have sine squared of theta minus sine of theta minus 2 is equal to 0. You might be asking yourself like, whoa, all right. These sines, the previous problem had x's, these have sines. This is a little bit confusing. And if that's the case, that's okay, because I'm going to show you a way to think about it where the signs are not going to freak you out. So what we're going to do is we're going to replace the signs with x's. Okay, so wherever in this problem where there's a sign, we're literally just going to replace it with an x. Okay, so instead of sine squared, x squared. Instead of minus sine, minus x. And then minus 2, obviously there is no sign there. So this is helpful, or this can be a helpful strategy, because now it looks way more like that example that we just did. Okay, so once again, we're looking for two numbers multiply to the constant, which in this case is negative 2, and add to the middle coefficient, which in this case would be negative 1, because there is a 1 in front of that x. All right, so we have to think about this. Two numbers that multiply to negative 2 add up to negative 1. Well, what about negative 2, or what about 2 and negative 1? Let's try that out. 2 times negative 1 is equal to negative 2, but 2 plus negative 1 is equal to 1, so that doesn't work. Okay, what about negative 2 and 1? What about negative 2 and 1? Negative 2 and 1 gives me negative 2, and negative 2 plus 1 does give me negative 1, so that works. So it looks like our two numbers are negative 2 and 1. Okay, negative 2 and 1. So that means the factored form would be x minus 2 and x plus 1. All right, x minus 2, x plus 1. So once you get to the factored form, so once again, this is called factored form. So after you factor, you end up with factored form. Once you get to factored form, put the signs back in. Okay, so remember earlier where we replaced the signs with x's? We'll now replace the x's with signs. Okay, so put the signs back. Okay, so we have sine of theta minus 2 and sine of theta plus 1. So once again, we just reverse the switch that we made earlier in the problem. So now we solve it. Remember, we separate both these expressions, set them equal to 0, find our answer. So sine of theta minus 2 is equal to 0, sine of theta plus 1 is equal to 0. So we end up with, if we add 2 to both sides, and then we subtract 1 from both sides, sine of theta is equal to 2, sine of theta is equal to negative 1. Well, let's do the one on the right first. So let's see, where is sine equal to negative 1? Well, if we look it up on the unit circle, if we look up 3 pi over 2, the y value is negative 1 there, and it's the only angle measure on there that would give you that, well, between 0 and 2 pi, unless we, went around the circle if we wanted to. But since our answer has to be between 0 and 2 pi, we don't have to do that. So theta is equal to 3 pi over 2. That's the only answer for that one. Excuse me. So, well, now let's look at the second one. I'm sorry, let's look at the one on the left. The sine of theta is equal to 2. All right, let's see. So when is the y value equal to 2 on the unit circle? Well, if I look on the unit circle, so if I look at each of the points, let's see, there's a point that has square root of 2 over 2, so that doesn't work. There's a point that has 1/2, that doesn't work. There's a point that has square root of 3 over 2, that doesn't work. There's a point that has 1, that doesn't work. It just so happens there is no point on the unit circle where the y value is 2. There is no point on the unit circle where the y value is 2. Hence, it's no solution. That first equation has no solution, and that can happen sometimes. Okay, there will be instances in which there will not be solutions for one of the parts of your equation. In this case, there was no solution for the sine of theta equaling 2. Because once again, there is no point on the unit circle where the y value is equal to 2. So that means our only answer is 3 pi over 2. Okay, so hopefully that was a good, not only quick review of the bell ringer, but also a quick rundown of how to solve trig equations using factoring. So this is not a huge part of our units. I mean, it's one of those things where on our test or quiz, you'll probably get one problem like this. So it's not going to carry a lot of weight in this unit. It's more of a minor topic, but, you know, it's something that it's good to get you guys exposed to. Okay, so at this point, the on your own problems, for today's video are going to be posted on Desmos. Okay, so the on your own problems for today are going to be posted on Desmos, and I want you to do the on your own problems this time on Desmos. Okay, so don't post it on Google Classroom this time. I want you to do the on your own problems on Desmos. And really quickly, or to just pull them up, just in case there are Desmos issues. Let me make sure I write them down here too. There we go. No, made a mistake. Oh, here we go. So the two problems are sine squared of x plus 2 sine of x is equal to 0. That's one of them. And then the other one is cosine squared of x plus 4 cosine of x plus 3, is equal to 0. Okay, so those are the two on your own problems that you'll find on Desmos. And once again, I want you to do your work on Desmos. Okay, I want you to do your work on Desmos. I'm just posting them here just in case there are issues with Desmos or for whatever reason Desmos is down when you try to do the problems. But otherwise, that is today's lesson. As usual, let me know if any questions pop up. I hope you guys stay safe, and I hope you enjoy the rest of your days.